Hello, my name is Braden Stump, and I'm the Director of Product and Business Development here at Aerosol Devices, which is now a division of Handic Scientific. And I'm here today to do a short-ish training video on how to operate the BioSpot-GEM BSS 302 aerosol sampler. We're coming to this point assuming that you already know something about the instrument, or that you kind of know that you're setting out to sample aerosol of some kind. But if you haven't, there are other YouTube videos on the Aerosol Devices YouTube page on why our aerosol samplers are useful, why someone would want to use them. So the point of this video today specifically is to teach folks who have this instrument how to operate it, how to set it up in your experiment, and how to be successful in sampling with this very cool, flexible tool. So without any further ado, I'm going to start. Let's go on to next slide. So just, reiterating the purpose of this presentation, and I'm going to keep things pretty informal because I'll be unboxing as I go. I'm trying to, first off, go over a high-level overview on the BioSpot-GEM. So how the system operates, why this capture method is useful, although I probably won't get as much into why this capture method is useful, just because we have another video on it, as well as training on this product kind of assumes its usefulness because it's already been purchased, right? The other thing that we'll be doing is training new users on how to operate the machine. I'll be unboxing a unit as well as the liquid sampling accessories as well, to work through common hurdles, work through setup as much as possible. One of the things to note, if I don't cover it here, if there's something you want to know further, if you'd like a copy of the user manual, please feel free to reach out to us, or even to look at publications that our collaborators have put out. We have a lot of really good folks that work with us or work with our instrumentation that do things as good or better than we do. Sweet. So kicking things off, I'm going to do at least a brief rundown on the theory of operation behind the instrument. Once again, we go further into this in another video on our YouTube page, but I think it's really useful when learning how to operate this instrument to understand the underlying systems of what's going on here. So just thinking about what makes a water condensation growth tube sampler special, one of the biggest things that people are very interested in is in our wide size range of capture. So from 5 nanometers to about 10 microns, we are capturing with 90% and above efficiency, regardless of substrate on this sampler. And that's useful for any form of aerosol sampling. Bioaerosol sampling, yes, getting down into the virus range as well as up towards the bacteria range, but even beyond to chemistry, the semiconductor industry, anywhere where nanoparticles and micron-sized particles have a presence, this could be of use. Additionally, the water condensation growth tube samplers have this special additional ability to be very careful in gently collecting aerosol, and we have seen that be able to increase the viability of particle capture, specifically of bioaerosols, virus, bacteria, other microbes. And then finally, the coolest thing that I think, from a mechanical perspective about our instruments, is how you can concentrate or get samples onto a convenient substrate with this high efficiency. The BioSpot-GEM, as we'll talk about in a bit, has quite a few different options for sampling substrates. So be thinking about, what would be the ideal way you would want to sample your aerosol onto aluminum foil, a slide, a liquid vial, what volume of liquid in your liquid vial, a swab soaked in some material. The possibilities are pretty extensive depending on what your interest level is or what you'd like to do with your experimentation in aerosol sampling. Great. So into our crash course theory on how this instrument operates. Thanks to Aerosol Dynamics and Suzanne Herring and Aranza, Steve, Greg, everyone else at Aerosol Dynamics, there comes this tool that Aerosol Devices has now licensed from Aerosol Dynamics, which is a water condensation growth tube collector, which base is a water condensation growth tube. So what happens here, and I'll skip to the next slide just to kind of be on the same page with everything, is 3 governing systems that allow very small aerosol of a variety of sizes to be captured. So you have aerosol, you have air with particles in it being pulled through an inlet of an instrument at laminar flow. And then you have a wet wick, so this wall along the outside of that tube being wetted with water. And then you have these 3 temperature stages here. And we'll talk about these more in depth, but effectively what this does is mimic the inside of the human lung and force condensation to occur around particles in this growth tube, forming droplets. So the way that this is actually working, these 3 governing systems are airflow through the instrument, water along the wick, and different temperatures on these stages. And combined, as you have airflow flowing through this wick, you will see particles kind of going at a relative pace through the growth tube. Those wet walls forming this capacity for vapor to come and condense onto particles. And then as these particles cross from this cold conditioner section into this initiator section, there's this kind of fog, the supersaturation that forces particles down to 5 nanometers to be condensed on and form droplet nuclei. And what that means is those droplets grow and grow and grow to be 3 to 4 microns in size in the case of the BioSpot-GEM. And that allows them to be captured pretty efficiently, very efficiently onto liquid substrates, solid substrates, swabs, whatever substrate you can inertially take a droplet and shoot it at a little surface to impact gently onto. There are some additional benefits to this technology. Specifically, the moderated 3rd section allows you to pull a little bit of vapor back out of the flow so everything isn't too soupy and condensation forming when it's actually being captured. So you've got these grown droplets, but you're not oversaturating, creating too much liquid downstream. Additionally, from the biological side of things, you can see that the temperature inside of the growth tube really does not get even as high as the wall temperature. So it's pretty moderate in there for bioaerosol, which is quite nice. And I won't go into, why you would be interested in this technology, but it's good to be reassured that, temperature conditions are good. This droplet growth that's happening, it's all a gentle process. So 3 things to keep in mind when we're getting ready for operation. The way that this growth tube works scientifically is airflow of the right flow rate, temperatures being correct along the growth tube, and a wet wall on the wick. Great. So yeah, just wanted to also be able to kind of start the process off prior to opening the instrument to show a few use cases and examples of the instrument in operation. Specifically, you can see here on this slide, courtesy this picture of Marina Nieto Caballero at CSU. The BioSpot-GEM, very portable, can be in a lot of different locations, and can sample onto a lot of different substrates. You see here a swab, which we will be getting into and trying out more. So a swab that can be installed and screwed in and sampled onto for sampling with genomic preservative soaked on it, or even sampling without genomic preservative. We also have a little 5.6, which takes 5 millimeter substrate well here that you can sample onto as kind of a flat solid surface. And even liquid vials with a variable volume between about 300 to 600 microliters of liquid. Long story short, the BioSpot-GEM, especially in our product catalog, it's portable, it's easy to use. It's meant to be able to be used as an indoor or outdoor research aerosol sampling tool. And it's got this 1.2 liter per minute flow rate. All of the samples that you'll see here, you'll need to manually interact with unless you're creating some sort of external system to swap those things for you. But great. I think it is time for section 2. So we're going to be unpacking a BioSpot-GEM and looking over how the instrument operates, how you would set up an experiment, and running the instrument just to see how it actually works, when you're operating it. However, I know less fun prior to actually getting hands on the instrument is thinking about experimental setup. One of the ways to make sure that the BioSpot-GEM is successful, and one of the ways that I have seen pitfalls for users in the past, is to be thinking about your aerosol sampling setup prior to operating your instrument, getting it in the field or getting it plugged into your chamber or whatever you're sampling with or from. So a few things to think about. One, really make sure if you are sampling aerosol of any kind into the BioSpot-GEM, which you will be, it's an aerosol sampler, to make sure that if you're connecting anything to the inlet of the instrument, to make sure that that tubing, the fittings, everything along that path is made of metal or conductive material. I would be more than happy to recommend McMaster-Carr has static dissipative conductive tubing to make sure that you don't see losses along the way. But the recommendation here is that aerosol has natural charge to it, and you will lose any, potentially some random amount of aerosol to the walls of your fittings, tubing, etc., prior to sampling if you don't have static dissipative tubing in your system. And random losses prior to sampling means it's not entering your instrument, it's not being sequenced or PCR or cultured. And we also don't have a way of knowing what the problem is not with the instrument, right? It's upstream. So be thinking about conductive material if you're choosing to tube to some other location. Additionally, think about where you'd like to place the inlet of your instrument. With this instrument being smaller and being more portable, it can be closer to an aerosol source, but also with its smaller flow rate, you'll also want to make sure that it is as close to an aerosol source as possible so that you're pulling in the particulate that you're wanting to sample. If you're, the BioSpot-GEM is between your source and then you've got an HVAC vent here in the middle sucking air out, the currents of flow that you have in a certain area might keep you from capturing what you're wanting to capture. There are plenty of references on our website and studies that are really useful to look at as well for where people have placed instrumentation when they're looking to get an ambient sample. And finally, making sure that tubing has no tight 90-degree bends. This is, less of a concern as long as you're not seeing kinks or very tight bends in your tubing, but especially if you're trying to capture bacteria or other, above 1 micron sized particles, you don't want something where you're going to impact something on a curve prior to it entering the instrument and potentially losing it. One other big recommendation that I would make prior to starting the sampling process, if you can, is try to figure out what the concentration of aerosol that you're sampling is. I would say this applies more to chamber sampling studies, so in lab sampling studies, than it does ambient studies. But there are plenty of times, specifically with the BioSpot-GEM, that if you are sampling too high of a concentration of aerosol, you're going to see potentially a little bit of reduced returns on sampling. And I'm going to show here as to why. Once the aerosol concentration in the growth tube of the instrument is at or above about the 1 × 10⁵ number per cc mark, which is quite a bit, right? It's like smoking a cigarette into the inlet of the instrument is, up on the high end sort of thing. So not necessarily ambient room aerosol count, but it's definitely something that a nebulizer could generate, that a chamber could generate. You will start to see that there is not enough vapor to condense on all of the particles to sample fully efficiently. So on our specifications list for our instrument, we promise that 90% and up sampling from 0 particles per cc up to 10⁵ particles per cc. So that's kind of the last fourth secret sauce recommendation that I would make, is make an effort to know your aerosol concentration. If you don't have the ability to, and you're not seeing the results that you want to, feel free to contact aerosol devices. But if you have access to a tool to measure your aerosol concentration down to the same range that the BioSpot-GEM has, so from 5 nanometer to 10 micron, then that's fantastic. That's very helpful, I would say, in diagnosing and making sure everything makes sense. Cool. One of the things that I'm going to bring up is the user manual for the instrument and the website page of the instrument prior to taking the instrument and kind of looking at the nuts and bolts, just because I want to be able to show the resources that you'll have if you run into any trouble. So first, on the products page of the Aerosol Devices website, you will see the BioSpot-GEM page. This is the same as our brochure, talks about the use cases of the instrument, talks about the different collection methods that are available. And we'll actually, highlight these for a second. The 3 primary ways that you can sample onto an aerosol sample into the BioSpot-GEM is onto a swab, onto this solid spot, which you can put substrates into that solid spot, or into liquid vials that come in the optional liquid sampling kit. Depending on what you've purchased, you may not have a liquid sampling kit on your GEM, but it's just a stock kit. You're always welcome to purchase it and add it to your sampling setup down the road. And then just wanted to highlight particle concentration range, like we talked about, is there. How efficient our instrument is at capturing particles is here on the page as well. And if you're looking for environmental operating conditions, other things like that, the weight of the instrument, there is additional information on our website. Another thing that, just because we talked about it a moment ago, the references section of our website also does discuss where the sampler, and where our samplers generally have been placed for successful sampling. A very good example, this paper from University of Florida, I'll zoom in on it here, actually does show the location of the sampler that they were using in reference to HVAC returns, HVAC supplies, where they think the flow of air is going. So just something to consider. Placement of the instrument can also be important in ambient studies. Great. And then I will also just briefly pull up the user manual. I'm happy to send a PDF version of this if any of you ever have requests to do so. But generally speaking, this has been well edited and has a bunch of information on it that should be of use to any team utilizing the instrument. So a lot of stuff in here, but if I have not mentioned something, the user manual likely has it. Great. I think that is now time for us to start looking at the instrument as a whole and start digging into it. Great. So first off, the instrument itself comes in, we like to call it a pizza box, but it is effectively kind of a pre-packed box that has everything that you will need for sampling inside of it. The user manual is up here in the top area, and then I will angle this down. The actual sampler is held in the center, and there are additional boxes with items in there. So as we enter the unpacking process, I'll kind of be showing stuff and then needing to pull it out. First and foremost, the power cable and power supply. This power supply will be plugging into the back of the instrument via this, as you can see, keyed power port. And then depending on which region you are in, international or in the United States, there is a power plug that then plugs into this brick this way. So this is the primary means of power for the BioSpot-GEM. I'll set this to the side, but we will be plugging the instrument in down the road. Additionally, let's pull out the, we'll do the sample kit first. The BioSpot-GEM sampling kit. This is if you are doing swab sampling more so. So this instrument was initially designed for the industrial hygiene, indoor air quality world. I'm going to move the camera up slightly. So what you'll end up seeing is a lot of things related to that application. Yeah, this is the better move. Perfect. So the box itself has a lot of things for swab sampling, with it being dipped in genomic preservative. If that is part of your sample pipeline, you'll probably be interested in this and buying more of these. If this isn't your sampling pipeline, it will have some useful accessories, but won't necessarily be your primary use case for the instrument. So just in no particular order, these jars here, you will see are jars that go onto the bottom of the BioSpot-GEM to catch excess wastewater dripping off of the wick. As you can see, they have a little bit of this water absorptive material in them. This is supposed to be, if you're sampling bioaerosol, a way to make sure that that bioaerosol is not still in solution or in some way, gross, that you would need to dispose of it or inactivate it prior to disposing. You don't need to operate with this absorptive material in here. If it's great for your sampling pipeline, wonderful, but it is something that you can also toss as needed if you prefer to just dispose of water. Cool. The next thing you'll see in here is a 60 milliliter syringe. This syringe is for loading water into the BioSpot-GEM, specifically into the water supply bags for the BioSpot-GEM. The way that these work, which I won't be doing currently because I would not like to waste one of these, is you end up popping the top off of this bag here, which is like a little IV bag, and then inserting this IV spike into the bag itself. You'll then take, here we go, this cap off, and you'll be using this lure lock connection on this syringe to push and load water into this supply bag. These water supplies, this is the water that wets the wick of the growth tube that allows droplets to be grown and particles to be captured efficiently. So you'll want to make sure that this is filled whenever you're starting a sample. The type of water that you'll be wanting to put into this bag is either distilled water or a cleaner water, so deionized water, whatever you can get that is not going to, increase the gunk on the wick over time. But yeah, long story short, once this is installed here, you can load this with water, and then you'll be unscrewing this and then capping it again, or you'll be installing it onto the BioSpot-GEM. I'm going to rebag this just to make it easier for us to grab down the road, but that is the water supply. There are also multiple of these, and if you at any point would prefer or need to throw these away, we have plenty of these and can send you more, and your kit comes with multiples of them. Great. The next thing you'll see in this kit is 8x, I believe, of these sterile swab packs. These swabs, as you will see in your user manual, are, one moment, sorry, adjusting slightly. Here we go. These swabs are little flat swabs that will actually go into the BioSpot-GEM to be sampled directly onto, with a break-off swab for these little PCR sequencing, closed-top sterile vials here. So it's really useful if your sampling pipeline is for, this genomic sequencing PCR, anything where you're sampling into genomic preservative, because you can go straight to your sample capture vial from there. Cool. The next thing you will see in this container is DNA RNA shield. This is from Zymo Research. This is actually what you dip your swabs in. You can see in the user manual the exact process for how you'd run an SOP like this. But there's 8 milliliters of it with pipettes to transfer it onto your swab to be able to start a sample of some kind. But this material, all that it does is preserve DNA and RNA at even room temperature for quite a bit longer. So it's useful for swab sampling to make sure that you're retaining the quality of your biological samples. Not in this box because this is a demo instrument. There's also a sample vial mailing box that allows you to ship samples back if you so choose, if you're going to have us send those out for sequencing or PCR. But if you're doing those in-house, that isn't as much of a big deal. Great. So that is the sampling kit. After that, I'll angle this downward. There we go. After that is the accessories kit in the instrument. So this accessories kit will have some optional items in it. I will note what those optional items are as we are utilizing them. And here we go. Sweet. So the first item in this kit is another water bag and supply. We've already gone through the proper usage of this, so we can continue onward. The next thing that you'll see in the accessories kits here is a inlet filter with a specific connection to fit onto the top of your BioSpot-GEM. These are for two purposes. One, an inlet filter like this is, it keeps particles from entering the instrument. So if you're ever needing to do a control test, a blank test, something where you're not sampling bioaerosol or aerosol of any kind, you can place it on the inlet of your instrument and be able to take a truly controlled sample. This is pretty useful when you are testing to make sure you don't have cross-contamination between samples, that the BioSpot-GEM isn't introducing something that would cause your samples to fail, etc. But it is also useful for drying your instrument out. You place this on the inlet, you won't be adding any additional particulate or mass to the instrument while you're making sure to dry the instrument out with fresh air. Great. Additionally, you will see here, just for usage for the swab sampling pipeline, a little 3D printed microcentrifuge rack. This is just for holding your vials if you're taking a certain number of samples for your little microcentrifuge vials. A useful thing if you're operating with that sampling pipeline, but not a necessary item depending on what you're actively doing. Additionally, you will see a USB flash drive here preloaded with the GEM's firmware. You probably will not need this the majority of the time, as the GEM is not an instrument that has firmware updates often, as it is a pretty mature instrument, but good to know of. You'll also see 2 hex keys, which we will be using when we replace the sampling setup on the bottom and also install wicks. So I will set these to the side. You will see a USB A to B cable. This is for connecting your instrument to a computer. We probably won't be getting into connecting an instrument to a computer now, but we'll put it in kind of a pin in it for this is in the user manual if you need to ever change any settings on the instrument. You will also see a hemostat, I believe is what they're called, for helping install the wicks in a sterile fashion into your instrument, as the wicks to the instrument are removable. You will see a additional removal a wastewater container that you can remove and reinstall. And then this is pretty neat, and we'll go over this in a moment. You also have a little well insert for completing solid sampling on your BioSpot-GEM. I'll try to get this towards the camera view. This little sampling tool allows you to sample into a small 5mm well with some form of 5mm punch that you can find for a very highly concentrated dry sample, or at least solid sample. Additionally, you will see 2 packs of GEM wicks. Each BioSpot-GEM has actually 3 internal parallel growth tubes that converge together in the center. So this plus this, these 3 wicks plus this bottom, what we call a flow cone, is 1 set of wicks. So you will see that each instrument comes with 2 sets. You can always get more from us. They're very inexpensive, and we can also send them to you as needed. So be in touch if you ever have that need. This demo instrument that I'm utilizing now is a bit older. So there we go. We'll pull this out. The liquid sampling setup is also here. However, the liquid sampling setup that I have here is notably missing a few small parts. I will be able to grab those parts as needed and be able to show this, but most of the time when you see this liquid sampling assembly, it should also have a few additional components on top of here to make it easier to swap out. You will also in each liquid sampling kit see 2 of these liquid sampling vials with a conical bottom. These are made of polycarbonate. They are autoclavable. You can clean them with alcohol, hydrogen peroxide, etc. And they are pressed into, I will push this in, pressed into this liquid sampling apparatus in here to take a liquid sample. That said, there will be 2 of them in any purchased BioSpot-GEM liquid sampling kit. And then there will also be 2 ported vials that have a 16th-inch barbed tube fitting port at the bottom as well. I just do not have access to those right now. Great. So in that case, without any further ado, sorry, pulling all of this stuff out, setting it to the side. I'm going to replace most of the accessories in here. And then, then we're going to start looking at the actual BioSpot-GEM. Great. Let's set this to the side. So when you actually pull the BioSpot-GEM out of the box, you will see there's just a small piece of foam here. And then the instrument just comes straight up and out of the foam that it sits in. Great. And I will set this box now down to the side. Cool. So move my chair over here. So in order to not make things too repetitive, I am going to go over the actual gem and how it looks itself. But once again, feel free to skip past this part if you are looking for more specific information on the BioSpot-GEM. So you'll see here first a red inlet cap, and also the inlet of the BioSpot-GEM itself. This inlet is 10 millimeters in outer diameter. So 10 millimeter tubing will of course fit to it. But if you are in the United States and you're looking for an imperial option, 3/8 of an inch is 9.525 millimeters. So any 3/8 inch inner diameter soft tubing, such as static dissipative tubing, fits onto this very nicely, and it's very easy to adapt to. The other option that you would have at your disposal is any 10 millimeter fittings, which are possible to find. Aerosol devices use them pretty frequently. So if you have questions, feel free to ask us. So inlet cap is here. Additionally, you will see these 4 lights on the instrument. These 4 lights effectively are the user interface of the instrument. We tried from our instrumentation that's more researchy to instead make something that is very clear about what is happening in sampling at a given time. So these 4 lights are all you will need to know what is going on with the instrument when it is turned on. Additionally, the buttons that you have the option to sample with are here. So there is a set dial position, there is a dial position 1 and a dial position 2. We will talk about those in a moment, but the gist is that the set position is for letting the instrument warm up and reach temperature to be ready in between samples. And then positions 1 and 2 are different preset sampling time lengths to take a sample of a given time. Great, let's flip this around. So we are now here at the back of the instrument. So right here on the instrument, this top port here, this USB-B port, is the data stream port. This port is for utilizing your USB A to B cable here and connecting one end into this port and then one end into a USB port on your laptop. Not going to be doing that because I don't know how that will interfere with Zoom. I don't think it'll interfere with Zoom, but long story short, if you're ever needing to change any of the settings on your instrument, notably the amount of time you would like the BioSpot-GEM to sample, you will need to utilize this and a program on your computer. BioSpot-GEM manual's got all the information on that you'll need, but that is the thing that you'll need to know is that kind of custom changes to settings will require that USB cable. Additionally, there's the firmware load port here. You really honestly won't need to be doing that too much, so we'll probably leave that out just because firmware very rarely changes on the BioSpot-GEM. There's a power on-off switch here. The power on, as you can see, the 1 position is up, and that is directly above the power cable plug-in port. I will quickly grab the power here, power cable. As you can see, this is directional and there's a flat side. That flat side points up when you plug it into the instrument. Here we go. And now you're ready to plug it in and turn it on, hypothetically. We're going to go over the rest of the instrument first, but that is how you plug it in and turn it on when it is ready. Great. Additional items of note. There's a fuse here on the bottom of the instrument. This is not something that you'll need to be frequently interacting with. This here is the exhaust port of the instrument. This exhaust port has a little additional fitting that we leave in for folks utilizing the sampler, primarily because it allows you to use 1/8 inch inner diameter tubing to run this exhaust somewhere else if you are not wanting the exhaust of your instrument to exhaust back into the room. That said, the flow of this system is heavily filtered after it does its bioaerosol sampling. So you don't have anything to worry about. But if you're looking to run it through a HEPA filter, run it back into your hood, that is an easy option for porting the entire flow of the system to be in the same loop. Finally, there's a little bracket here, and we'll actually do this attachment right now for attaching your water bag into place. So under normal operation conditions, you will be removing your water bag, snapping off this bottom end, installing the IV spike, popping the cap off of this, filling this with water, and then, oop, I dropped my cap. There we go. Utilizing this port here, this supply water port, to attach this kind of a twist motion to attach your liquid supply line in, and then your bag sits here on the top of your tray. We're going to leave this unplugged just because I'm not looking to get the instrument wet today and need to have it be dried out or need to remove the wicks that I install, but that is what you would do in a normal circumstance. Great. Bring this back in the bag. Finally, we'll be reviewing the bottom of the instrument. I'm going to remove the cap just in case I forget to prior to turning sampling on. So, a few things of note about the bottom of the BioSpot-GEM. One, you will see here, this is where the waste jar, where the removal water, the excess water coming off of the wick prior to the droplet laden aerosol flow from the sample goes. What we'll do is set the instrument down on its side for a moment. You can just unscrew this. What we'll actually do is we'll take the clear one from the sampling kit, because these are just used for transport. We'll take the clear one from this sampling kit and screw it in and install it here. You'll want to make sure this is pretty tight. Reason being is if this is loose, water will not be removed off of the wick and your sample area will flood. Should not be great. Additionally, you'll see two other things of note here. You'll see kind of a sampling area down here. And actually, there we go, angle it up this way. This area here, this is a nozzle heating sleeve kind of surrounding. What you'll see here is your swab sampling setup. And I'll point this out and get this a little bit closer to the camera in a moment, but what I want to show off is you kind of have two pieces of tubing attaching into that swab sampling setup. These, the black line here is the airflow line, and the clear line here is the water flow line. They are of barb sizes, so they cannot be swapped and messed up, but I like to point that out. So, getting a little bit closer, as you can see, on the front of the instrument, currently has this swab sampling setup installed. This swab sampling setup allows you to unscrew, and then we'll grab a swab from the swab sampling kit. But you can see a swab fits into this screw-in mounted piece. So the way that you do this is take a sterile swab, pop it open, and then I believe you take the cap out, although biological folks may know better than me. And what you'll be looking to do, there are ridged lines on the side of this swab holder. So you'll be pushing this in, from what I understand, kind of rotating it a little bit just to make sure that it sticks in nicely. And you want the line of the flat part of the swab to be aligned with the lines on the swab holder itself. This is just because the aerosol jet is going to be sampling down onto it. Then you'll be doing is reinstalling. I am less good at this because I'm holding, there we go, tightening this into place until this is parallel again, and that will allow you to take an aerosol sample onto the swab. That is mechanical installation. Under normal sampling conditions, you would be putting genomic preservative of some kind onto the swab or whatever you're doing onto the swab first. However, wanted to show just how it is actually mechanically installed and pulled out. Once your sample would be complete, you would then remove this swab, and definitely not with my hand. You would be doing this with gloves, of course. Pull this out. I believe dropping this in, snapping the end off, and capping the vial to be done. And then that will allow you to store and transport your vial in a safe, easy to operate. Cool. Now that we've kind of showed off swab sampling and how that works mechanically, the one other thing that I wanted to show off prior to kind of moving away from this is solid surface sampling. As you can see, there's another ported piece that unscrews from the bottom here. During swab operation, you'll of course want this to be tight and in place. However, if instead of sampling onto a swab, you would prefer to sample onto one of these solid inserts, what you can do is you can take this piece here and take the concave end here, placing it inward, and you can actually install this into the gem to sample with high efficiency onto this solid sampling surface. And the way that that works, I'll be picking this up, please forgive me. There we go. I'm not getting the angle of this superbly right. He was being on camera. There we go. Sorry about that. And then that tightens in. Make sure the O-ring is engaged by turning it nice and tight. Take your sample, and then you can unscrew and remove it. Yes, sorry, wait one moment as I screw this back in. Apologies. It is, they're big chunky threads, so it's pretty easy to make sure it is actually lined up, but I am just having trouble with the angle, which I am trying to do it. I might just set it down here. And you can also flip the instrument to the side. I apologize in advance for all the people watching this YouTube video where that won't be cut out because I do not know how to edit YouTube videos yet. Probably could learn, but hey, it's worth, showing off the trial and error when you're first operating a sampler. Cool. Prior to showing off the rest of operation of this instrument, I am going to show off how to install the wicks to this instrument, and then also how to install the liquid sampling setup. Primarily because I want to get all of the things that should be done with the instrument off out of the way first, and then we can then turn the instrument on and actually show how samples are run regardless of sampling substrate. So what I'm going to do, just to make things a bit easier, is get our sampling kit out of the way and show off how swapping sampling apparatuses goes and also how installing the wick goes. So on the instrument itself, you will see that the majority, the majority of screws on the instrument that you'll be accessing are either opened with this larger hex key or this smaller hex key. If you're ever needing to open the top inlet of the instrument, for example, which isn't often that you'll need to do this, but if you ever need to clean it, stuff like that, your larger hex key allows you to open it. That said, that is not what we will be accessing when we are replacing the wicks of the instrument. Also, I think it goes without saying, you want to make sure that, you've got, that you ran the instrument for a while prior to turning it on its side, that you don't have water leaking from somewhere and that bags are removed and stuff like that. So in order to replace the wicks or to install the wicks on an instrument that has arrived to you, we'll be removing this bottom swab sampling kit area to get access to where the wicks go. You will see there are 2 screws. I'll actually show them off. Here, here and here. They're captive screws, so they won't come out as you're unscrewing them, which is useful, but just also make sure that once they're loose, you won't need to make sure that it's all the way out prior to, actively pulling to remove that sampling apparatus. Great. That has come all the way out. And this, great. So you can kind of see cap screws are loose. I can now, and it does have what are those called? Excuse me. There are dowel pins, excuse me, here and here that will cause you to need to make small adjustments just to make sure that everything is in place nicely. But now, as you can see, these 3 holes here, these are the actual, that's where the growth tube of the instrument is. And then here at the bottom where these pieces of tubing are converging, this is actually where we're going to be installing the flow cone of the instrument. So these are where the wicks actually go. One thing that I'm going to do prior to installing the wicks is show how you swap in the liquid sampling apparatus. So what I'm going to do here, just going to zoom this down for a second, is when you're swapping the liquid sampling apparatus, you'll need to disconnect the air and wastewater tubing lines. So under normal circumstances, if I had a full liquid sampling kit, this liquid sampling kit that you see here should also come with this top part here, as well as this top part here where the flow cone sits. Because this is a demo instrument that I was just, operating to unpack today, I don't have those parts, so we'll need to swap those in place. However, this will show how to disassemble these components and put them on. So if you ever remove them for cleaning, you know how that can be done. So if anything, we're all learning something today. How perfect. So the way that you'll do that, you won't normally need to do this. As a reminder, the smaller hex key of the 2 in your kit can be utilized to pop open these 2 captive screws coming from the opposing direction. And then this just pops out, comes out of there. Perfect. I would also make sure to exercise caution and make sure that the dowel pins are aligned on the plastic piece as well, because these parts are not captive screwed. I was wrong in saying that 5 seconds ago, because this is just a small insulator piece. So when you're wanting to reinstall this onto your liquid sampling kit or your swab sampling kit, you'll just want to make sure that everything is still lined up the same way. I believe I actually have it backwards. There we go. Perfect. So when you're actually installing this back onto the liquid sampling apparatus, you want to make sure that the dowel pin area is over here to the side. Should be pretty easy to tighten down. Now that you have this liquid sampling apparatus set up on here, ready to go, so imagine with me that you have already reinstalled your wicks, because I'm going to be putting the swab sampling apparatus back on. This, once you've got your wicks installed, will push back on the exact same way that we installed the swab sampling apparatus, and we will use our larger of the 2 hex keys to tighten this into place. Whoop. There we go. I'm not going to tighten this on all the way because we, of course, will be installing the swab sampling tool. After that, you will be using your water removal line on the smaller of the 2 barbs, and then your sample line here to attach into the air line. However, when you receive a actual liquid sampling kit and not just the demo parts that I have here, there will also be, instead of this black line, a trap bottle, so something to catch excess liquid that might fall out of your vial here. So you'll actually be replacing this whole line with a small water bottle that will be able to catch excess liquid. This is discussed in your user manual, but just kind of wanted to show what installation of these parts look like. So then we'll flip this up. When you're operating a liquid sample, the last and final step, other than turning the instrument on and running it, will be, there we go, take this liquid vial to push it in to the O-ring groove here inside of that liquid sampling zone. Sometimes some isopropyl alcohol or some water on the new O-ring can make it easier to install and push it in here to where it sits. And then you can turn your sample on, run it, and then remove it and pipette it out. When you're actually doing liquid samples, something of note, so I've pushed this in. Moment. There we go. You will need to start with liquid in your vial. The prescribed amount that we typically recommend to start with is about 400 microliters, although you can start with anywhere in the range from 300 to 600 microliters and be totally fine. The key is you will need liquid in there to start. Many people doing bioaerosol sampling will start with phosphate buffered saline, bovine albumin. You can use water. You can sample into genomic preservative, artificial saliva, anything that you find to be adequate for your sampling application. Great. Now we are going to go back and uninstall the liquid sampling apparatus. And I might actually check, by the way, if I have had the instrument on the wrong side the whole time. We will be able to see. Once again, a good reason to check the user manual. Oh yeah, sorry. I was supposed to have this flipped this way the whole time. A very good reason to check the user manual. Regardless, it doesn't affect anything other than ease of being able to actually access stuff, right? But this should actually help make lining things up a bit easier. Great. And then typically you would have a setup like this, once again, on this swab sampling setup. Since I do not have one on hand currently, I'm going to be removing these parts and reinstalling them onto the BioSpot-GEM's swab sampling setup. But once again, not something that you will need to do every time that you swap from swab sampling to liquid sampling when you get a production unit. Great. Reinstall that. Cool. And then the final step before we turn the instruments on is actually installing the wicks. Installing the wicks is, once again, a crucial step to the instrument actually operating properly and sampling aerosol efficiently. It is what allows water to actually condense around particles. So I will be putting on some nitrile gloves for this task. What we will be doing is we will be installing these 3 wicks into these 3 cavities here. There is also, you can see a little key on the end for what direction the tips of those wicks are oriented. Finally, we'll also be installing this, what we call flow cone, onto the end of the sampling end of the actual swab holder. So let's get to it. You will pull out your hemostat here. So this is just useful for pushing and installing stuff in. However, if you've got gloves on, you can also do this by hand. We will pop open our container of wicks. As you can see, these do have a little keyed end to them. And then you'll be able to, I believe it says in the manual, to grab with the hemostat to install. Now, the manual does say that the wick wetting process is to be done, you can do it outside of the BioSpot-GEM, and that is true. But that does assume that the wicks are out each time you're about to start a sample. Another way that is perfectly the exact same amount of acceptable to wet the wick is to insert the wicks into the instrument, leave them in there for the entire time you're operating, and to turn the instrument on and off to use sampling counts or small injections of water to wet the wick instead. These little tabs, by the way, in here that you can see are also great ways to grab something to pull the wicks out. As you can see, I've pushed these in with the tab into the little groove so that they are oriented the correct direction and flush. There we go. Great. Final step in wick installation prior to buttoning things up is removing the flow cone here. You can see this also has keys in it as well. That will sit flat when it has been installed correctly. We will then install this in the way that we did before, pressing this into place, making sure that the dowel pins engage, pressing in the water removal tubing line onto that barb, pressing in the airflow line onto that barb, making sure it's engaged all the way so we have good airflow through the instrument, and screwing the instrument's bottom piece in place. Now, just as a point of reassurance, you will not have to install wicks like this, do all of this pre-setup stuff in advance every time you're operating the instrument. Just so happens that we're going over everything because this is a training video. The only reason I bring that up is that, you know, the actual process for running a sample with the BioSpot-GEM is pretty fast once you have everything set up. So with that said, final thing that we're going to do is turn the instrument on, and then we'll go into part 3 talking about special considerations. Great. I'm going to grab the power cable with the special port on the bottom, and then I'll be flipping the power switch to turn the instrument on. Under normal circumstances, if you're not wanting to keep the instrument dry, like I was, you will be putting the water bag into the shelf, having it already plugged in at the supply water line port here, because when you turn the instrument on, it will immediately start injecting water into the instrument. Great. So taking the power cable here, plugging this in, plugging this into the power brick as we did already, plugging into a wall plug. Fantastic. And now, we are going to be able to turn the instrument on. I'm going to change the camera angle a bit here. Great. So now, flipping the instrument on, doesn't matter which position the dial is in, although we prefer that it's in the set position. When you turn the instrument on, you'll be able to hear the pump turn on and small clicking sounds coming from the inside of the instrument. Those clicks are 70 automatic injections of water from the water bag into the growth tube of the instrument. What this will do is this will be slowly adding water to the wick to wet it over time to allow you to have that efficient droplet condensation that allows the sampler to work. So perfectly normal, whenever the instrument is operating, you'll want to make sure turning it on, the inlet cap is off because the airflow pump will be running and then the water will start injecting onto the wick. Once those 70 counts are complete, the one thing that you'll want to look out for is if you're choosing to wet the wick instead of submerging it in water and installing it, but instead by wetting the wick, by letting the bag inject water onto the wick, if you don't see water dripping out into the jar on the bottom here, then that means that the wick still needs to be wet more. The wick, when it is fully saturated, will start to have excess water be pulled into this jar. So what you want to do is after 70 injection counts have clicked, if you don't see water down here, turn the instrument off and then turn it back on. Typically, this takes from a fully dry wick about 3 to 4 times to do this. But the long story short is you are looking to saturate your wick fully so that it is fully wet. The reason I bring that up is, if the wicks, if you've left it overnight after a night of sampling and it's, been cleaned and it's kind of sitting still, might not need 3 to 4 full rounds of injections to be clean. However, it's something to keep an eye out for when you're adding and installing new dry wicks into the system. The next thing that will be happening is after those injections are completed, the instrument will then be trying to warm up and get to the temperature stages on the instrument needed to sample efficiently. When it is ready, these lights will change. The user manual of the instrument goes into exactly what these lights mean. With this being kind of a brief introduction, I'm going to keep it as pretty simple for how to run your first sample for now. But something to note is that once the instrument reaches its temperatures and it says that it's ready to sample, we will then be turning the dial of this instrument to one of the 2 positions, which each of these 2 positions, 1 and 2, denote different lengths of sample time. Specifically, these are user settable. I believe they start at 5 minutes and 10 minutes. However, you can change these by use of your USB cable. The idea of this is to have a pre-programmed setup so that you turn it to position 1, run your sample. When it's done, the pump stops and you turn it back to the set position to swap in and start your next sample. So yeah, as this is getting down to temperature, we're going to leave this in place and talk a little bit about decontamination. But first, I'm going to move my chair just a little bit. There we go. Great. So something of large note on this instrument, specifically the BioSpot-GEM, is that although the wicks are easily replaceable, they are not cleanable with all of the materials that you might want to clean with. Specifically, these wicks are much less expensive, much easier to replace than our other instruments' wicks. However, they cannot be cleaned with alcohol. Isopropyl alcohol, methanol, ethanol are all off limits for decontamination on the wicks specifically. The reason being they wash the surfactant off that keeps the wicks able to condense water onto the particles. You can still clean the BioSpot-GEM with isopropyl. However, you'll need to remove the wicks first to do that, which makes it a little bit less attractive of an option. That said, the whole plumbing flow path, as well as the instrument itself, can be cleaned with hydrogen peroxide fully. So you can soak the wicks in hydrogen peroxide. You can put hydrogen peroxide in the water bag, inject it in the instrument. You can use VHP, vaporized hydrogen peroxide, as a method to decontaminate the instrument as a whole. However, the one thing that we like to recommend with a water condensation-based growth tube is to flush your wick with double the amount of water that you have used of cleaning fluid after completing a cleaning operation. And yeah, we're still just waiting for this to get down to temperature, but it's a good time to talk decontamination. The frequency at which you do decontaminations depends very much on the amount of samples that you're running, the types of samples that you are running, the risk that you are looking to mitigate, the sensitivity of your downstream method. The general rules of thumb that we like to give for people doing chamber studies where they're generating a large amount of bioaerosol that might gunk up their system over time, or they'd be worried about, cross-contamination. We actually only recommend at the end of a day of sampling. Some folks go as far as to the end of a week of sampling. For ambient sampling campaigns, we recommend somewhere between probably about the end of a week of sampling so that it's not left over the weekend with stuff in it. Ambient sampling just has a lot less of a bioaerosol or aerosol load on the instrument. The reason why we recommend so effectively, not needing to clean between every sample is because the flow path on the growth tube is a straight line going to a nozzle into a sample. If particles, which they aren't necessarily want to do, were to somehow impact on the wall of the wick material, all that excess water is being removed to your waste bottle and isn't entering your sample. But then also, most of the time when aerosol like that's hitting a surface and impacting, it would need some sort of physical force to be to come off of the wall and re-enter your airflow stream. So most of the time we're not seeing cross-contamination between samples in that way. So, excuse me. The reason that I bring that up is because a way to check for cross-contamination is to utilize your inlet filter right here. There we go. To utilize your inlet filter on the inlet of your instrument, of course, to run a blank sample and to see if you are having cross-contamination. So the easiest way to make sure that your cleaning procedure, your SOP, your standard operating procedure works for the instrument that you have is to run the length of samples you'd like to run prior to running a cleaning methodology, do a full no particle control, and then afterwards run your PCR, your culturing, your downstream processes after that to confirm that your sample really was, not a hit, so to speak. And with that, our sampler has gotten to temperatures and it's ready to sample. So as you can see, the light is flashing, and all that we need to do is start a sample, other than, of course, at this point, we would be removing and installing our swab, right? Or our solid sample or our liquid vial, is to turn this dial from set to position 1. What that will do is that will immediately start the pump and it will start a sample. Just kind of as a technical thing, since the growth tube is always at the right temperatures, and then the wick is wet from us making sure that the wick is wet on the instrument, temperature correct, wick is wet. The last step is the airflow actually running through the instrument to determine a sample. So the way that we determine the sample length is how long the air pump is on. So a 5-minute sample, as set here in position 1, is 5 minutes of the air pump being on, and then it turns off at the end of the 5 minutes. And the lights will change on the instrument to denote the end of that 5-minute sample. At the end of that sample, you will pop your preferred sampling method out, unscrew your sample, your swab. You can pull out your flat, flat solid sample, or remove your liquid vial, extract it out, install your next one, and you should be able to continue swapping samples from there. It should be a pretty quick process. Since I don't want to wait for this whole entire sample to end to talk further about the instrument, I am going to turn the instrument off. However, again, if I have done anything else that you have questions on, feel free to email. So I'm going to remove this cable, and we're going to talk about special considerations as a last parting note before this quote unquote short video is over. There we go. Right, I'm going to go back to sharing screen again. Cool. So yeah, once again, manual, very useful. Here we go. Special considerations. It took us a while to get here to part 3, but this should be pretty fast. Special considerations effectively just means more dynamic use cases than what you saw here. We've already talked about how connecting the instrument via a USB A to B cable is important, and talked about in the manual as to how you do it to set exact sample times and temperatures on your instrument. Additionally, one big thing that we'll want to talk about when it comes to sampling is liquid level change. So if you are sampling for under an hour, this is not for you. If you're sampling with swabs or with solid samples, this is not for you. However, if you're sampling both into a liquid vial, looking for viability or just for longer liquid samples, and are sampling for over an hour, typically this is where this conversation will come up. So be thinking about the concentration of aerosol where you're sampling, the length of time of your sample, and the volume of sample you'd like to maintain for your downstream process. I'm not going to go over all of this because this is a more advanced topic, But what I wanted to briefly bring up is that when you are sampling into our liquid vials with volume, 300 to 600 microliters, the droplets from your, grown aerosol are coming through and being sampled into this vial, and they have water around them. Additionally, you have fully saturated airflow with water vapor in it from your moderator stage coming out. And that causes the liquid level in this vial to go up and down over time, to condense upward and then evaporate downward. You're not seeing active dilution, adding or subtracting of real liquid in here. It is just additional condensate or evaporation in your sample, as well as the addition of little droplets in here. And there are ways to control that. It is actually a function of your sample temperature in your liquid vial and your moderator temperature on the instrument. However, it is a pretty difficult process to control. The gist of this, sampling rundown is you'll want to turn the moderator temperature on your instrument up if you want to be condensing more water into your vial. So if you're losing liquid, turn your moderator temperature up. If you're gaining too much liquid, turn your moderator temperature down. Please also contact Aerosol Devices if you have questions about this. But long story short, if you're trying to complete long length liquid samples into a vial on your instrument, to contact Aerosol Devices and we can walk you through best cases for sampling. One last thing, we've already talked about decontamination of the instrument, and thinking about contamination, we think about cross-contamination, but then we also think about safety of your team. This is the BioSpot-GEM's flow path, so you can see water injection going into the initiator of the wicks here, and then additional water removal flow occurring here, and then airflow and sample flow occurring onto your swab through a filter and out to your airflow pump. This is where, if you're putting a filter here, no particles are getting into your airflow path. And then finally, the remainder of your airflow path, if you're inserting H2O2 into your supply bag, it's cleaning the whole line leading up to your initiator. There are sections of the BioSpot-GEM's flow path that, because they are filtered aggressively, and they are also only paths where airflow should go due to there being orifices here that liquid cannot reach and should not reach. Notably, you never want your waste jar to overfill and stuff like that. But that said, the pathway is double filtered, so the exhaust is going to be definitely safe and totally fine. But notably, not all of the flow path is fully cleaned by liquid, if that makes sense, when you are doing a decontamination. Finally, the outside of your case, you can clean with VHP, you can clean with alcohol, you can wipe it down with Clorox wipe. It is powder-coated, aluminum, so it should be fine for many different cleaning methods. All right, I know that this has been long, and I have definitely been informal along the way. I'm sure that I've made some mistakes in this long first kind of initial training session on the BioSpot-GEM, but hopefully this is the start to a conversation. If you have purchased an Aerosol Devices instrument, the whole entire Aerosol Devices and beyond our parent company, Handic Scientific, is here to help you be successful. It is our job. It is what we want to do. It is how we make sure that we are doing the right thing and serving our customers well. So please be in contact. My email is at the bottom of this YouTube video and on the screen right there. We want to help make your sampling as successful as possible. So don't be bashful. Please feel free to reach out to us. This has been training on the BioSpot-GEM BSS 302 for both liquid sampling and then also for all of the different sampling methods that there are. And I have been Braden Stump at Handic Scientific /Aerosol Devices. Thank you very much for your time and best of luck in sampling.